Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Center for New American Security in Washington, D.C., where we're talking to Amir Husain, who is the founder and CEO of SparkCognition, an artificial intelligence company that was founded in 2013 in sunny Austin, Texas. So you're a Silicon Valley company that's in Texas. Amir, thanks for joining us.
Thank you very much, Vago.
You are a leading artificial intelligence thinker. You've got a book coming out, The Sentient Machine, which I want to ask you about a little bit. And with John Allen, you wrote an article in Proceedings in July titled Hyperwar, and with retired Marine Corps General John Allen, who is on your advisory board, but he's also the new president of the Brookings Institution, so congratulations on that, and we'll congratulate the general as well. I want to ask you, talk to us a little bit about what you guys do and how you guys are differentiating yourselves. You know, where do you fit into the ecosystem, and how are you differentiating yourselves in a very, very crowded marketplace?
So you're right. SparkCognition, is really focused on core AI issues. Right now, the AI market is occupied by a large number of companies, and there's money to be had. Venture capitalists are putting in a lot of investment into these companies. But I still feel that there are fundamental technology and science challenges that need to be addressed. And one of the more difficult ones is in how automated the process of applying AI can be. If you require domain experts for every problem, you simply won't be able to scale the application of AI. And one of the big innovations that SparkCognition has made is in the area of automated model building, where the idea is that you can expose our algorithms to the underlying data, and the algorithms then imply the physics of the problem automatically and build models automatically. So in some sense, these cognitive pipelines replicate the thought process that goes on in the mind of a human data scientist. Now, what does that mean? What that means is that you can take data of a variety of types. You can take, for example, sensor data coming from a large industrial pump. You can take sensor data coming from a turbine. You can take similar information coming from military systems. But then it doesn't just have to be structured numbers. It can also be text. And all of this input can be processed by our algorithms, and a model can be built that can then do things like predict when a system will fail, or find an anomaly that nobody else may have noted, or optimize performance in a certain way. So that's the crux of what we do. And since our launch in April of 2014, actually, we've now acquired close to 100 of the largest customers in the US, principally in three areas: defense and national security, industry and energy, and finance.
How have you guys managed to do that? I mean, is it the cognitive infrastructure platform that you guys have that you think is key to that? I mean, how have you managed to wrap up so much business so quickly?
Well, as far as how we've enabled automated model building, it really has been by inventing new algorithms. There's been a lot of progress made in this area, with deep learning now being very effective, and reinforcement learning, which, by the way, is the technique, for example, that the Google DeepMind team used to defeat the world's best Go player at that very difficult game. But we have created new algorithms that are able to look at industrial sensor data in very deep ways and extract from that, again, like I said, the latent physics of the process. And the results have been quite spectacular. We've also made some innovations in the space of natural language processing, so being able to take written words, English text, for example, and being able to reason from it and gauge from it far more than simplistic constructs like sentiment. For example, to be able to build what we call ontologies, or the structure of terms of art used in a document, and then to be able to reason over those automatically. Or to look at things written out in a table and infer from their placement in the table what the importance of that term is and what the relationship of that term is with another term also in the table. So these sorts of more elaborate reasoning processes, these are all new capabilities that we've developed. And the way that we've put them all together ends up solving some near-term, very valuable problems. For example, for Honeywell, being able to provide prescriptive maintenance on aircraft from Dassault, as an example, that they service and provide parts for. So 30 minutes before the aircraft lands, the system is able to piece together from hundreds of different submanuals, is pieced together a solution that is presented to a maintenance tech. And that prescriptive solution using natural language processing technology is a very simplified list of what the individual needs to go through. And this, of course, beats the multi-hour workflow of going out and finding prescriptions manually, looking at books, manuals that have been put together by different vendors. So this is just one very tangible example. Another one is being able to predict turbine failure well in advance of what even an expert would be able to do. So, the implications of these types of insights are in the tens of millions of dollars, sometimes hundreds of millions of dollars. And so the application of this technology and our novel algorithms is actually solving high dollar value problems. And those two things coming together, it works and it solves big problems, is what really has allowed us to gain the traction that we have.